Aloha and welcome to this screencast on unit testing and Meteor applications. And I want to start by saying why do we want to test? And as I've said before, the major reason why I test is because I get stressed out when I'm building a big system and I make a change and I can't run tests to ensure that what I just changed didn't break something, because as systems get large, it's hard to actually keep the whole system in your mind at once and understand exactly what the impact of changes are. Tests are also good to when a test fails. It's usually because it was examining a small part of the system, so you can immediately narrow down the cause of the location of the error, and ideally testing shouldn't require a tremendous amount of investment of time, at least I'll say in the domain of kind of web application stuff. If you're getting into safety critical, life critical systems, you might have tests that, your testing overhead might be tremendous, and that's appropriate. But, in the case of, a software engineering class and building, web apps, simple systems, hopefully we can figure out ways to test in kind of a lightweight fashion that still enables the trajectory of development to go fast, and you have acceptable levels of quality. You can have some bugs in there, but no one's going to be hurt by that. So there's kind of three levels. There's a lot of different ways to slice up the pie of testing, but I want to just say that three common ways that are particularly applicable in the case of Meteor and web application development is the idea of a unit, integration, and acceptance test. The unit tests are the smallest little ones, where you're testing literally maybe just a single function or a single collection in your database or something like that. And in the case of Meteor, that means you'll either be purely on the client side or purely on the server side. Integration tests are the next level up from that, where you're trying to see if multiple modules work together in a coherent fashion or in an appropriate fashion. So, for example, in the case of Meteor, you might have a template and the backing collections, and you want to make sure that those things work together. And then the final level up is an acceptance test. Normally for that, in the case of Meteor and web application development, what you're going to do is you're going to have a running version of the system, and you're going to use Selenium or something to basically manipulate the browser and do a login and step through various pages, and so that you're kind of simulating what an actual user might experience as they use the system. So for this particular screencast, we're going to focus just on the unit testing part of it. That's a very important part. If you have a nice set of unit tests, actually, you can find a lot of problems very quickly when, in fact, you're introducing changes and modifications, and you can see the ripple effect really quickly. So unit tests actually have a lot of kind of return on investment. Plus, they're pretty simple, particularly for the server side to write, and so I can show you how to do that pretty quickly. So what we're going to do now is look at unit testing in particular, and I'm going to start off by showing you how unit testing would work just for a plain kind of vanilla JavaScript, and then we'll show how that applies to Meteor. Now it turns out that in JavaScript, the way the JavaScript community has kind of split things up, they have a set of libraries for assertion that they combine with. You typically pick one of these libraries for writing assertions, and you combine it with a library for actually running the tests and reporting on results. So you have these idea of assertion libraries and test run libraries that can be mixed and matched, and that produces a tremendous amount of debate and noise in the community about what to do. It just needlessly complicates things. If you look at Java, the Java world, you got JUnit, and so it's easy. JavaScript, you got like a zillion, a few different choices for all these things, and it's makes it more complicated. So we're just going to pick two, Chai and Mocha, and they're fine, work great, easy. work well with Meteor, and so you don't have to worry about those other ones. They're all good too, but you know, you got to pick something, so that this is what we're going to pick. So assertion language is the way that you check whether a condition is satisfied. Okay, so let's say foo is a variable. It has some data in it, or it's structured in some way as a result of, you know, the way you want your system to be. And so what you want is a way to easily express characteristics of foo that should be true in order for your system to be correct. So here's an example. It's really, you know, you can read this really easy. Expect foo to be a string. I mean, you know, hard to not understand what that particular assertion is. Or expect foo to equal bar, or expect foo to have length of 3. You know, all these things are, you know, really quite obvious when you read them, and that's what's nice about assertion languages, is they put a lot of energy into kind of figuring out how to make these things very, very readable. Okay, so that's the assertion language. That, you know, checks that a condition is true, but doesn't involve any of the machinery for actually, for example, setting up the state of foo so you could actually test that these conditions are true, or, you know, running things and running the set of tests that embed these assertions and then reporting the results. And that's what the test runner does. But before I get there, let me just say that, you know, you will want to go to the Chai library documentation, because there's a lot of these different, you know, primitives: to, be, been, is, that, which, and, you know, that you chain together to make these interesting conditions. So that, you know, I give you a few examples here, but you can go to this documentation to learn about all the other ones. And it's really pretty awesome, all the different things they have there. So anyway, now you have to combine your assertion library, which in our case is going to be Chai, with a test runner library, which is responsible for kind of setting up the state that you want to test and then reporting the results. So here's an example of the Mocha test runner, some Mocha test runner code, which involves these functions: a describe function, which has a string followed by a function, and inside that function you have this function called it, which is also part of Mocha, and with a string that says what should be true, and then inside you have a function which actually tries to do the test. And so you can see here, in this case, the function is just a single line of Chai code. So we say foo must be a string, and then you see in here, expect foo to be a string. Foo must have length 3, expect foo to have length 3. You know, that kind of thing. So the Mocha code is in green, the Chai assertion code is in yellow. Okay, so that's how you combine these assertion libraries with these test runner libraries. And so if you do everything correctly, you can basically you know, bring up a page that the Mocha library kind of provides the template for you, and the bringing up of that page in a browser will run your tests and then report the results for you. So, you know, here we have this code that says foo must be a string, must have length 3. If that code were to be run, and I'll show you how that works in a second, then you get a page that looks like that, which is pretty cool. It tells you whether or not it's a string. It tells you that those two it clauses were true for that particular describe clause of foo. Okay? So how does that actually work in practice? Here's a little more detail. So here is a test.html file, and this is pretty much copied directly from the Mocha documentation. So you're just going to have this HTML file, and it's going to have this code, and the only thing you're actually going to change is you need to load the specific code from your system that you want to test. And so I'm loading some of numbers.js, which has some JavaScript functions in there, which I'm interested in testing. And then I'm loading a separate file here, some of numbers.test.js, which contains my test code, which combines the Mocha test runner code and the Chai assertions. And then all this other stuff is just to run Mocha. And when all that runs, this is the page. When you load this page, this is what's actually produced on the page. Okay? So let's look at this sum of numbers.test.js, okay? And what we can see here is it looks really almost exactly the same as what I showed you here. And the only kind of difference is it's the indentation's a little different. I needed to use this chai global variable, which I didn't have in the example. And then finally, I had to set up the state of foo, and I thought that was, I could just set the state of foo to be the string foo, and then it would be a string and it would have length 3. So both of these things would pass. And again, you can go to the mochajs.org site, and you can find out all the amazing things that Mocha can do. Only a small fraction of which you need to know about in order to do the testing that we're going to have in this class. So let me now kind of talk through this code in more detail. Okay, so this is this sum of numbers problem from earlier in the semester, and the idea is we're just at this point we're just trying to learn simple JavaScript, very simple JavaScript, and so we wrote a way of summing up an array of numbers in a few different ways. One was using a for loop, and then we had a console.log to see if we'd done it the right way, and then we tried to sum up an array of numbers using a while loop, and here's the code for it, and then we had a console.log to see if it was right, and then we had a way to do it using recursion, which looks like this, and then we printed that out, and then we used the underscore library, and we used the reduce method. Okay, so we got the one-liner version of it, which was totally the cool way, and then of course we printed that out. Okay, so we have this file of JavaScript, and then we have an index.html, which just basically loads it. And so very early on the semester, if we were trying to understand, running JavaScript in the browser, what we do, or in IntelliJ, we can click this. It brings up the page. The page, of course, doesn't display anything, but we had those console.logs, and so we saw output 4 times the number 10, which is because that's the result of the console.log, sum for, sum while, sum recursion, sum the simple way. Okay, so back then in our infancy of JavaScript programming, we didn't know any better about how to figure out whether what we were doing was right, other than to produce these console.log statements and then go over into the browser and check the console to see if the right number was printed out. Okay, well that's very kind of barbaric, and now we're going to fix that by enabling enabling a mechanism to actually test the code. And so the way you do that in this kind of pure, non-Meteor kind of environment is actually pretty cool. We're gonna, we had the index.html, which we were using to run our JavaScript before. What we're going to do now is provide another page called test. It can be anything, but I'm calling it test.html, but it's independent from the page that runs our application, test.html, and it loads all that Mocha stuff, like we were talking about before, plus it loads the code for our application, plus it loads a file containing our tests. Okay, so what I've done essentially is I took our previous application and I've added 2 files. I've added an HTML file which is going to run the tests, and I've added a JavaScript file which contains the tests. And these are completely different from the set of files for the application. So that's a nice kind of modularity thing there. Okay, so if we go to our test.html and we do the exact same thing, okay, what we get, instead of having to go into the browser and see if everything was okay, we get this page printed out that shows that all our tests ran fine. And if we go back and we do something like, just for grins, let's change that to be 11, okay? And then I go back into test.html. If we run that, what we find is, okay, we got an error on this one, and we see that we should return 10 for test nums. We expected 10 to equal 11. Okay, and in fact, if I was writing this, more appropriately, I would say should return 11 for test nums. Okay, and trying to figure out why we're getting an ESLint error. Oh, I know why. Because I have to declare these as globals to ESLint because they're being loaded from another file. It's because they're being loaded inside of this HTML. It will be defined because this file is loaded previous to that one. It will be defined, but ESLint doesn't know that. So in here I have to declare it as global to indicate that I know that sum of numbers.js will always be loaded before this file is loaded. So anyway, the point being is if I'd written it this way, should return 11 for test numbers, expect sum the simple way test numbers to equal 11, and then I go to my test and run that. Now you can see expected 10, which is what was actually produced, to equal 11, should return 11 for test nums. Okay, so, and you can use different kinds of, you can get this into continuous integration. There's all sorts of ways you could trigger this and determine that it's results. But obviously this is way better than going into the console each time and trying to figure out whether those outputs are actually right. This is a much better way to check whether or not your program is correct or not. So let's so in review, right? When we're doing JavaScript testing, we have to pick a test runner, and we're going to pick Mocha. And then for Mocha, for doing regular old JavaScript testing, you get this HTML file, which they show you in their documentation. I basically just copied and pasted it. You're going to load the code you want tested. You're going to write some tests and load that. And then you just, kind of display this file, and you run your tests. And I'm going to change this back to 10 because I can't stand the idea that test is going to fail. So let's just save that out, go to here, and we can run it, and we can see everything's all good. Okay, so there you have it. That's the simple use of testing. You can imagine your JavaScript code could get very, very complicated, and as long as you can use these describe statements, you can set up the state of your system so that you can invoke these expectations where you've got some kind of function call here that's going to return some value, and then you've got these chains which you can use to check should it throw an error, all these kind of different things you can check for, and then you just run these things through by retrieving the web page, and you'll find out whether your code is working. So that's really good. I want you to practice that, and I'll give you some example problems to look at. But right now, what we want to do is say, okay, now that we understand that we have test runners, we have assertion languages, we're going to write some test code, and then in the case of vanilla JavaScript, we're going to set up an HTML page which will run it. How do we translate that into Meteor? And in Meteor, it actually turns out to be, in a lot of ways, even simpler than that, because Meteor is going to take care of some of that setup for us. So the first thing I want to note is there is in the Meteor guide a whole section on testing. That's good to look at. Unfortunately, it's a little more. It almost is confusing. I'm going to be frank. You read this and you're just going to be confused. So just listen to me for the next 10 minutes. And when you get done with it, you'll see that there's like 10% of this that you need to actually read in order to do server-side unit testing, which is going to get you 50% of the way there to a well-tested system. And then we'll deal with the other 50% at a later fashion. But right now, all you need to know in a nutshell to get started in doing things is you're going to have to add the practical Meteor :Mocha package. You do a Meteor add practical Meteor :Mocha. You're going to create some test data files, and all you have to do for that is include .test. In the name of the file, and that will ensure that they're not loaded when you're just running your application, but when you run your application in this special test mode, they will be loaded. So to run the test, you're going to say, instead of Meteor, npm Meteor run, you're going to say Meteor test, and then you're going to specify the driver package, which is practical Meteor Mocha, and then you're going to specify a port to output the results on. And 3100 is kind of the convention. Okay, so let's quickly look at an example, via screen dumps, and then I'll go through it in the browser. Whoa. So you can see on the server side in my API directory, that's where I define the data model. And I'm going to say that for doing unit tests on the server side in Meteor, the high impact place to focus is the set of collections. In other words, your data model. Like, are you building objects? Are you storing documents into MongoDB with the appropriate structure? When you have queries on that collection of documents, are your queries designed right? And do things, interrelate in the appropriate way? That's really good. If you know that your set of collections work correctly, you can start to build the higher layers with, somewhat fearlessly. Okay, so what we're going to do is we're going to define for the two collections, the interest collection and the profile collection, we're going to define a set of tests that test each of these two collections in isolation. And of course, it's great to have a set of tests that test the interaction of collections. So you could have a whole other, kind of subdirectory where you have tests that test the entire, data model as a whole. But we're not going to show that because that's simple to do once you understand the basic idea. So to write a test in Meteor that tests the data model, you're going to write a file like this. It'll, if you're going to test the interest collection.js, then you just put this file in the same directory, but you'll have this .test. So that it won't be loaded except when you're testing. You got to do some imports. You got to do some ESLint stuff so that you don't get errors. And then you're going to say if meteor.isServer. You don't want this code to run on the client side, because on the client side, things aren't going to be defined or work correctly because the nature of, the way Meteor has different environments for client and server. So we wrap this code in this conditional to make sure that only on the server side will this test actually run. So we're going to have a describe. We're going to set up some state. We've got this Mocha thing that says before we actually run any of these tests, we're going to remove all the items from the database, and afterwards, each of these tests we're going to remove just to make sure that we always start off with a completely empty database. It's a simple way to do that. And then we have an it clause, which has a string to say what functions we're going to be testing, and then inside there you can see we just do some things, and then we call these expect functions. Expect interest is defined to be true, expect blah 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 to equal blah blah blah. What else? We have expect blah 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 to be false. So we just got all sorts of expect blah 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 to be true, expect blah 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 to equal blah blah blah, et cetera, et cetera. Okay, so it doesn't matter what I'm actually testing in here. What is important for you guys just to see is, well, how does this look? You've got an if, you check to see you're on the server side, you got a top level describe, you set up some state, and then you have some it clauses to make sure that things are right. Then you have to run it, and basically you call Meteor test minus driver package, practical Meteor Mocha, minus port 3100. Stuff starts up, and eventually you see this Mocha runner, run server test, starting server tests. And then in the browser, you get something that looks like this. Okay, and you can see it from all these little green check marks that everything passed. It also tells you how long things took, and it has some, built-in things like, I guess 82 milliseconds seems like a long time to Mocha for running this, so it flags it as red. But I don't know. I always ignore the time. I don't really care. So. And then there's a possibility of having stuff run on the client side, but we're only running stuff on the server side because we had that conditional. So we're only going to see the right-hand side of this. And that's good enough for now. Okay, so let's kind of go into this in a little bit more detail so you can see. So let's go into Bofolios. And and now you can see the actual, here's the interest collection, which is a class that, implements a Meteor or a Mongo database, Mongo collection. And here's that actual code that I was talking about earlier. Okay, and just like I said, you got a whole bunch of expect clauses. You have as many it clauses as you need to. Sometimes it's more convenient to test multiple things inside one block of code, so you can specify all of them here. What I'm doing basically is saying the interest collection is a class. It defines some methods like define, find name, etc. So in my test, I use this pound to say that I'm test in this it clause. I will test the define method that is in the interest collection class. So that's what these pound sign things kind of indicate. And similarly for profile collection, it's just the same kind of thing. I set up a profile, and then in this case I've got one it clause, and I go through and check all these properties that everything worked correctly. To run it, as you can see, I've got this, in the browser I had invoked Meteor npm run test watch, which was running the script inside package.json. Here's that script test watch. So that just is a little bit more convenient to type, Meteor npm run test watch than Meteor test -- driver package practical Meteor Mocha -- port 3100. And then finally, if I go to the browser and we look at localhost 3100, okay, it just runs every time we refresh this page. It actually runs it again, and you can see that everything worked fine. If just for grins you want to see things not work fine, we could change, expect interest is defined to be false, save that, go back to the browser, and it will rerun it, and now all of a sudden everything goes bad. Okay, so we can change that back to be true, save it out. Might as well go back to here so you can see that this test runner is watching the file system, and when it sees that code is something's been saved out, it will rebuild the application and rerun it. And so now we can see, and it will also actually refresh this page, which is pretty nice of it. And so now our problems have gone away and everything's passing. Okay, so that's an example of, in both folios, how you do server-side unit testing in Meteor. Conclusions: unit testing in JavaScript, if you just go out there and Google around, man, it's very confusing. All the different options, and it's hard to make any progress. That's why I made this little screencast, because just basically use Mocha, use Chai, follow the little templates that I've showed here, and in fact you can get started going quickly. There's not a lot of code to write. It's not a lot of code, it's not very hard. It's actually pretty easy to do vanilla JavaScript testing. To do it in Meteor, also not hard to do server-side unit testing, because there's a lot of support for it. You just basically have to create a test file, organize it, import the packages, and run that command, and you're in business. Okay, not to say that there aren't other things to do in Meteor testing that are much harder, but by restricting yourself to server-side unit testing, you can actually test a lot of stuff, a lot of important stuff in your application, namely your data model, in a fairly simple, lightweight, fast fashion. So that's a good win for software quality.